Okay, so we will talk about the finite automata with output. So far we have seen the output is either we are going to be a rejected state or a accepted state. So, output is just accepted state, accept or reject. So, that is the output. We have given a string, we have to say whether the string is accepted or rejected. So, that means at the end of the at the end of the string, after reading this, whether we are reaching to a accepted state or or rejected state. That is the output. Okay, so but there are some other output of this finite automata. So, we will discuss, basically we will discuss the two machine, Moore machine and Mealy machine. So, we will define that. So, we will discuss the two machines like Moore machine and Mealy machine. Okay. Moore machine is the output associated with the state, So, associated with the present state. Suppose we are at the state q. So, if we are at state q, we have the output like this. So, output associated with. So, each state is the output is a function of state, output associated with the state. But here in the Mealy machine, output associated with the transition. So, not only state, it is the input alphabet also. So, the symbol we are going to read and the current state, it will depend on the what will be the output. So, output associated with the transition function, with the transition. Okay. Anyway, we will formally define these two machines and their equivalences. So, first let us define the Moore machine. So, it is again a 6 tuple. So, Q is the finite set of state, sigma is the input alphabet and this is the output alphabet. This is the new one, delta, lambda is the output function and q 0. Okay. So, we know everything. This is the set of states which is finite. This is the input alphabet, set of input alphabet which is also finite bits, and this is the new one, this is the output alphabet which is also finite. Alphabets, and this delta is the transition function. So, delta is same. So, delta is function from, if it is depending on the which suppose we are in DF. So, delta is the function from q. Yeah. So, this is a deterministic finite automata and this lambda is the output function, like lambda is a function from q to output alphabet. So, this is the new lambda is the output function. So, suppose we are at state q, each state is associated with a output symbol, output alphabet. So, that is that will be determined by this function lambda. Okay. And this is the output alphabet set. So, like this. So, now suppose we are going to suppose it, so this is the situation. Suppose we have an input alphabet say input alphabet say A1, A2, AN, a string. Okay. And suppose this the delta under this transition, this is going like this. So, say let me write this. Yeah. So, suppose we are having, we are starting with Q0, we are reading this, suppose it will go to Q1 with A1 with A2 Q2 dot dot dot, we are reaching to starting from 0 Qn. So, these are the state it is visiting, and when you go to one state we have the output. So, what is the output string? Output string is, so we are visiting this, so lambda of Q0, lambda of Q1. So, all the states lambda of Q2 dot 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 lambda of Qn. So, length the length of this output string is n plus 1. So, it is n plus 1th length, because we are starting with Q0 without reaching without reading any symbol, and this is length is n. So, output string is having one more length than the input string. Okay. So, if input is epsilon, then the output will be lambda epsilon lambda Q0. Okay. This is the way. Now, can you just think of that DFA is a special case of this Moore machine? Yeah, DFA is a special case of Moore machine, because DFA, what is the output? Output is either it is accepting or it is rejecting. So, DFA is a Moore machine where lambda is DFA is a special case of Moore machine with lambda 0 or 1. I mean 0 1 means it is accepted, 0 means it is rejected state. So, we are labeling the states. So, in the DFA few states are accepted, few states are non accepted. So, those states which are accepted we can label them by 1. So, that is the lambda, and those states which are non accepted we can label them by 0. So, that is the way. With output alphabet, zero 1. So, maybe this is labeled to accepted state, and this is for rejected state. This is the way we can view this Moore machine, I mean DFA as a Moore machine. But in the Moore machine this could be anything, I mean it is not just 0 1, it could be any finite number of output alphabet. So, that is the general case. So, in that case it will not be a DFA. So, it is a general case, we are outputting the many symbols. So, it is not just 0 1. Okay, now, let us take an example of Moore machine, then we will go to the Mealy machine. Okay, so let us take an example of Moore machine. Okay. Now, suppose we have q is, we have few states, say q 0, q 1, q 2, q 3, and this is say 0 1, and output also says 0 1, output alphabet. And now, we have to define these two terms, one is lambda, one is delta, which is q comma q, and another one is lambda. So, let us have this. So, these are the state q 0, q 1, q 2, q 3. So, this is the starting state. Okay. Now, this is A is input alphabet, A is equal to 0, A is equal to 1, and suppose we are, so with q 0, so we can have a lambda over here also, this is lambda of q. Okay. So, now with q 0, if we are reading the 0, we will go to q 3. And lambda of q 0 is say so q 3 and lambda of q 3 say no lambda of, so this is basically lambda. So, lambda of q, so this is 0, this is, I will come back to that, this is q 1, and say q 1 of delta of q 1 0, this is say q 1 again. So, this is q 1, this is q 2, this is q 2, q 3, and this is q 3, q 0. Okay. Suppose this is a situation, and this side it is 0 1, 0 0. So, this is given the transition rules, and these are the corresponding value of the state. And for q 0, say this is say 0. So, lambda of q 0, lambda of q 0, where is the q 0? Q 0 is there, lambda of q 0 says 0. Okay. So, now suppose we have a input alphabet, given this, suppose we have a input alphabet say 0, 1 1 1, 4, length 4. So, we are at q 0, if we read 0, where it will go? If we read 0, it will go to q 3, and then we read 1, from q 3 with 1 we will go to q 0 again, and again so with 1, so this is 0. So, we read again 1, so with 1 we go to q 1, and from again we will read 1. So, with q 1, with 1 we go to q 2. So, this is the transitions of this for this input alphabet. Okay. So, now what will be the output? So, output will be lambda of q 0, lambda of q 3, lambda of q 0 again, lambda of q 1, lambda of q 2. So, lambda of q 0 says 0, and this is also 0, 0, 1, 0. So, this is of length 5 and this is of length 4. So, because that is the, so q 0 is the starting state. So, that will contribute in the output. So, if you draw this, it will be like this. If we draw this picture in a graphical form, so we are at q 0. So, q 0 say output is, I mean if we are at q 0, we will output 0. So, from q 0 with 0 we are going to have q 3, and if we are q 3, what is the output? 0. This is with 0, and with 1 we will go to q 1, and for Q1 what is the output? 1, and from Q1 if we read 0, we will go to Q1 again, and if we read 1, we go to Q2, and Q2 output is 0, and then from Q2 this is okay, and from Q3 if we again from Q2 if you see a 0, we will have a self loop over here, and if we see a 1, then we will go to, if we see a 1, we will go to Q3 with this, and from Q3 where we are going? From Q3 if we see a 0 here, and if we see a 1. So, this is the corresponding graph of this Moore machine, this is the transition. Okay. So, this is the example of a Moore machine. Now, we will define the Mealy machine. So, let us define the Mealy machine. So, Mealy machine, that the output is not only depend on the states, it will depend on the input tape which we are reading. So, it is depend on the transition function. So, earlier for the Moore machine it is depending on the fully on the states, but here it is depending on the state as well as the current state as well as the input alphabet we are reading. So, it is a function of delta, I mean it is a function of q cross this to, I mean the which tape we are, which input symbol we are reading. Okay. So, let me formally define this. So, this is again a 6 tuple q sigma delta lambda q 0. So, all are same over here. This is the finite number of set of states. So, this is the state set which is finite. This is the input alphabet set or input symbols which is also finite, and this is the output symbols which is also finite, output symbols. And now, this is the transition rule. Transition rule again a function from q cross, this is the deterministic rule, this one, and here the difference is here, this delta. Now, sorry, lambda, this was lambda, this was for Moore machine, it was a function of the state directly, but here it is a function of state and the input alphabet, it will go to the output alphabet, and this is the starting state. Okay. So, now how to read a input? So, suppose we have given a input say A1, A2. So, suppose you have given a input like this A1, A2, AN. Okay. Now, suppose with this input our state transition is like this. So, we are at Q0, with A1 we are going to Q1, with A2 we are going to Q2, with AN we are going to Qn. Okay. So, this is the state transition of for this input string. So, we are putting this string in a tape and we are reading the tape like this. Okay. Then what will be the output? So, earlier for Moore machine it was a lambda of this states only, but here it is a state as well as the input symbols. So, this is basically lambda of Q0 A1, because A1 we are reading. So, depending on this Q0 and this A1 it will output some value, lambda of Q1 A2, dot 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 lambda of q n minus 1 a n. And at the end what we have? At the end we have q n. So, lambda of q n, but we do not have anything to read. So, epsilon. So, this is epsilon, this is our convention. If we if the input is epsilon, output will be epsilon. So, that is why this size, this is n, input alphabet is input string is n, this is also size n, this is the difference. So, size is n in the both the cases. Earlier it was n plus 1, if the input is n symbols, then the output was n plus 1 symbol, because every state has a output. But here once we reach to the this once there is no symbol in the input alphabet, then we are nowhere to go. So, that is there. Okay. So, we will take an example of a Mealy machine, then it will be more clear. So, let us take a quick example. Example of Mealy machine. Okay, so let us have the earlier one. So, we have q is equal to, there are few states q 1, q 2, q 3, q 4, and suppose q 1 is the starting state. So, now say sigma and lambda is just 0 1. Okay. Now, let me define the transitions. So, transition is like this. So, we are at q 1 is the starting state, q 2, q 3, q 4, and here we have say input symbol is 0 and here we have input symbol is 1. So, for a given input symbol, we have for a given input symbol and the state, we have to define two functions. One is lambda and another one is delta. So, this is the two function we have to define. So, let us define the states where it is going. This is lambda of q a and this is delta of q a. So, this is output state where it is going and this is the output alphabet. So, suppose this is going to q 3 and this one is 0 and it is going to q 1, this one is 1, it is going to q 2, this one is 1 again, it is going to q 4. This is one example going to 1. Okay. And similarly, here also we can have this lambda of q comma a, delta of q comma a. Suppose this is like this, q 2 it is going, it is 0, then q 4 it is 0, then q 1 it is 1 and q 3 it is 0. Okay. Suppose this is the situation, and how to draw a graph for this? So, to draw a graph, suppose we are at q 1, the starting state. So, from q 1 where we are going? We are going to with 1 we are going to q 3, we are going to q 3. So, this is with 0. With 0 input we are going to q 3 and we are outputting 0. So, this we can write as this is the reading and this is the output. And with 1, so with 1 we are going to q 2, with 1 we are going to q 2 and we are outputting 0. So, this is 1 0. So, if we do this, complete this, then it is coming here 1 1, because from Q3 with 1 we are going to Q1 and outputting 1. This is the output what we are outputting, this other part like this. So, we have a Q4 over here and this is going 1 0 0 1, this is 1 0 and we have a self loop over here 0 1. Okay. And then from Q2 we can go to Q1, from Q2 with 0, from Q2 with 0 we can go to Q1 and output 1. So, with 0 output 1 like this. Anyway, we can complete this graph. So, this is the input alphabet, this is the output alphabet. So, now this output alphabet is a function of this. Now, how to read a input string? So, we can just quickly do that. Suppose our input is say 0 0 1 1, then the suppose 0 0 1 1 where we are going. So, we are starting from Q1. So, with 0 we are going to where? With 0 we are going to Q3 and the output is 0, and from Q3 again we are seeing a 0, from Q3 we are seeing a 0, we are going to Q2, but output is 1. So, 0 output is 1. So, from again we are seeing a 1 from Q2, we are seeing a 1, we are going to Q4, but output is Q4, output is 0, and from Q4 we are seeing a 0, 1. So, we are going to Q3 and we are outputting 0. So, what is the output? Output is this one, the other part of this 0 1 0 0. This is the output string. So, this in this example it is of same length. Okay. Thank you.